to us about spongy moths. So take it away, Will.
Hello everyone. As Willa said, my name is Will. I'm a rising fourth year PhD student in UVA's Environmental Sciences Department, and I study the spongy moth, which is an invasive species from Europe, the type of spongy moth we have here on the East Coast, and its implications for large-scale landscape-level ecosystem functions, things like tree mortality, tree growth, and carbon loss. And today I would love to chat with you all just a little bit about the history of the spongy moth's invasion and what its life cycle looks like, and what we can do on like an individual backyard scale to help manage spongy moth.
Hey,
Yes.
Will, are there any other names that people might know the spongy moth by?
Yes, excellent point. So spongy moth is its most recent common name. It was formerly known as the gypsy moth, so you may be familiar with it under that name. Its scientific name is Bimetria dispar, which is translated from the Latin as the disparate destroyer. So that refers to the males and females having what we call sexual dimorphism. They look very different from one another, and so for a while they thought they were different species entirely. So yeah, lots of common names. Spongy moth actually comes from the French la spongeuse, which just means the sponge, which refers to its egg mass, kind of looking a bit like a sponge. But I have passed out some cards here, inspired by Pokemon cards. But we will use these, and I will use your assistance here to help put together the story of the spongy moth. So that story begins here in, I would say, the mid-19th century, in 1860s, with a temperate hardwood forest on the East Coast. We've got lots of oak trees. Oaks are dominating in the wake of the chestnuts kind of on their way out. And we've got aspen, we've got birch, some maple, and no spongy moth. Yes. But if we were to take both of the cards, we've got our trees, the trees are growing, they're having a grand old time, but who do we think is kind of the next in this system as we move forward with the spongy moth history here in North America? If you were to take a look at the cards. Yes, Etienne, exactly. So if you have in front of you the wanted poster, this is the French amateur entomologist Etienne Léopold Bouleau. And in 1868, 1869, he decided it would be a grand old idea to bring the spongy moth over from Europe to North America. And there's been a lot of debate as to why he did this. One of the leading opinions is that he was looking at rising cotton prices in the wake of the Civil War and thought, what would be a good alternative fabric if cotton is too expensive? And he's like, obviously silk. That's what everyone here in 1850s America wants to be wearing is silk. And instead of importing silk moths from Eastern Asia that have been domesticated for so long they cannot survive on their own without assistance from people, he just went and grabbed a random moth from his home country over in France, the spongy moth, and delivered it to his home here in Medford, Massachusetts. Medford. And what? Medford, yeah. And predictably, like so many other stories involving invasive species, it escaped. And reports conflict as to whether or not Mr. Trouvelot tried to inform the Massachusetts government about the spongy moth, or whether he just sort of quietly disappeared once he saw his local forests being consumed by our little friend. And he did actually end up abandoning entomology entirely, the study of insects, and moved on to astronomy. But to this day, if you look him up on Wikipedia, you will see that he is really just known for the introduction of the spongy moth. So after Mr. Trouvelot in our cards here, what do we think is the next line in our story? Thinking about spongy moth's life history. If he's introduced the spongy moth, what do we have first? Adults or our larva, indeed. So this is a picture of a late-stage spongy moth larva. It's one of our red cards. It's our pest. And this is L5, L6. So when spongy moth hatch out of their eggs, they start off as really, really tiny caterpillars. There's not a whole lot to see there. But they eventually grow into these large black caterpillars with blue and red dots. It's really distinctive. It's hard to mistake them for other caterpillars once you know what to look for. And those hairs are kind of irritating to our skin. They don't have any sort of venom like that, but tussock moths are known for causing irritation. So we've got our L5, L6, which refers to our life stage. Male spongy moth go through 5 life stages. Female spongy moth go through 6. And this is the stage when they are consuming the most leaf material. Now, spongy moth is one of the top 100 invasive species worldwide. And according to the IUCN's Red List, it's like the International Union for the Conservation of Nature, and it has achieved this status of being one of the most problematic invasive species for 2 reasons. The first is that it is a generalist. We've got our 3 different hosts here. A lot of species, they just prefer eating one type of plant, but this one can feed on over 160 different species of plants here in North America. It is the quintessential generalist, and because of that, it can reach really high population densities. These are known as outbreaks. So that's another card in here, but we're getting a little bit ahead of ourselves. From our larva, what comes next? What comes out of the larva when we're thinking about butterflies and moths? Yes, it comes our cocoons. I don't actually have a cocoon here. That would have been a good card to include. But we've got our 2 adults, the male and female of our caterpillars. The males are that mottled brown and black, and the females are the white. The female is actually what is in the cowl that you've been knitting this summer is the female spongy moth. And females of the European subspecies can't actually fly. The males can, but this is really what's been limiting the spongy moth spread here in the United States, what's keeping it contained. It's just past the Mississippi River, and it's kind of down into southern Virginia, but it hasn't spread beyond around 30% of its potential range here in the US. And in large part, that is due to the fact that those females cannot fly. So they are limited by those short jumps each generation as they spread westward. But when something could be climate, could be decline in their natural enemies, something happens and those populations are able to undergo a sudden, rapid increase in their population density, which is what we call an outbreak. That should be the other black card. If you look at the tree trunk on there, you might be able to see that it is covered in spongy moth caterpillars. So we can get, if you're just wandering around in a non-outbreak year, you may find that you don't see any spongy moth at all. They're there, they're just really, really hard to find. But in an outbreak, they can defoliate entire canopies. So all of these different species that they're consuming, mostly oaks, a lot of our poplars and our birches, they are completely defoliated down to the twig. And this can happen for 1 year, it could happen for 2, 3 years in a row, and therein lies so many of the drivers of damage in the system. Because trees, when they get repeatedly damaged like that, year after year without any time to recover, is when they start kind of dying off due to lack of carbon being brought in through those leaves, other stressors like drought, they weren't able to take in enough water because of the loss of leaves, and then you have secondary pests and pathogens, root borers and fungus and all sorts of nasty things that like to inhabit trees, but only once they are weakened. So lots of vectors of mortality here in our spongy moth system because of those outbreaks. So this was way back, 1868, 1869, was Trouvelot introduces the spongy moth, and over the next 10 years, most of New England is under massive outbreak. Trees are dying left and right, and by 1905, the Forest Service is saying, dang, we have to do something here. And they begin what later becomes sort of the largest efforts to find a biological control agent ever undertaken by the US government. And they found 34 different species that will either prey upon or parasitize spongy moth larvae or eggs or pupa and help to curb the populations in their native habitats. But biological control studies were not as rigorous back in 1905 as they are today. So while they found species that parasitize the spongy moth, they didn't make sure that it was only the spongy moth before they introduced them to North America. Tale as old as time. And so, of course, they introduced a bunch of generalists. Around 12 of them were able to actually establish successfully here in North America. So taking a look at our last few cards here, our yellow and our purple ones, these are our parasitoids and our pathogens. Parasitoids refer to those animals that are parasites of our spongy moth larvae, and during the course of that parasite's development, they do kill the host. So we've got two here. The unlike pimpla, which is an ichneumon wasp. They have these really long ovipositors, and they weren't wildly successful, but they were introduced from Japan. And the elegant tachinid fly kind of looks a bit like a housefly you see on the other yellow card. This one is notable, actually not for what it does to the spongy moth, but what it did to two other species. It successfully extirpated the invasive brown-tailed moth. We rarely see that species anymore, so that was a win.
Yeah.
But it is also responsible for the decline of the large American silk moths in the eastern US. So things like the Cecropia moth, the Luna moth, those really big, colorful moths that we used to get have been, kind of precipitously declining since the early 1900s, in large part to this particular parasitoid. So, and around that same time, they discovered a virus, the nucleopolyhedrosis virus. Kind of looks like the clusters of grapes on the purple card. And this particular virus is spongy moth specific. It's sort of like the spongy moth's supercalifragilisticexpialidocious. It's like the Lymantrian disparate multicapsid nucleopolyhedrosis instead. So we've got this virus here. It is incredibly successful at targeting the spongy moth. It causes zombification. So after they're infected, it'll proliferate inside their bodies. The caterpillar will be driven to climb to the top of a tree, where it then sort of just pops. And it spreads all sorts of little particles all over the place that then go on and infect subsequent caterpillars. So this is what we call like a density-dependent mechanism, where the more caterpillars we have, the more virus we have. And so as the outbreak persists over the course of those 2-3 years, the population is more likely to crash because of the virus. And so for a long time, this was what was causing these cyclical rise and fall in outbreak density. We would see kind of like every, 8 to 11 years, there'd be a big boom in spongy moth population density that would then crash, largely because of this virus. But then in 1989, we come to our last card here, is Entomophaga maiamiga, a fungus that was accidentally introduced from Japan that targeted the spongy moth specifically. And it has kept, in New England, the spongy moth population at really, really low density levels for something like 35 years. So it's been very successful, completely by accident. They did not intend to introduce this. It has spread throughout most of the range, and the big thing is it is able to kill caterpillars at both high and low densities. So it'll very frequently keep them from reaching outbreak status to begin with. However, the thing that's a big concern with this fungus is that it does best in cool and dry conditions. And so, of course, what's going on in the background? Of course, global climate change. And so in the eastern US, we are seeing more frequent and droughts that are lasting for longer periods of time. And so there's a lot of concern about how effective this fungus is going to be moving forward. There was a big outbreak that started back in New England in 2016 through 2018, and it was really the first one that we'd seen since the introduction of this fungus. And they are just becoming all the more frequent in the Northeast. So there is some question as to, what's going to happen next? Is spongy moth going to keep spreading? Is fungus going to keep it under control? We're not really sure. That's one of those big open questions in spongy moth research right now, is understanding what releases it to outbreak, what is entomophaga going to look like under climate change, and where is the spongy moth going next? So, I hope you enjoyed learning about the spongy moth, its history of invasion here in the US. I'd be happy to answer any questions you have. And if there is any card that you feel particularly drawn to, by all means, feel free to take that home with you as a memento of the spongy moth. And on the back is a reference to the Slow the Spread program, which is the Forest Service main efforts to control the spongy moth. So they will provide you a lot more information than I can in one evening about how the government is working to keep this at a manageable density.
That was awesome. Yeah, thank you. So, what could people do?
Great question. Yes, what can we do? So for a long time, people tried all sorts of things like lead arsenate and DDT, and that's, not, we know now that those cause way more problems than they actually solve. And the good thing about spongy moth is that on its own, because we've got these host-specific pathogens, most of those populations will decline by themselves. But say you have a tree in your yard that you're fond of, it's providing shade, and you are finding a bunch of egg masses on it. Like they look like small, maybe quarter-sized fuzzy blobs, because the female moths will rub all of the hair on their abdomen off to cover the egg mass in an effort to keep parasites from getting into it. So if you find those like little white blobs, it can look like maybe a spider egg sac, you can always scrape them off of your tree. You'll find them in the leaf litter. They like going inside tire wells and on the lower trunk of the tree. So that is one of the things that we encourage like citizen scientists and people that are concerned about managing it on a household level to do, is look for those egg masses. They show up in August after the adult moths have kind of mated for the season, and they will stick around all the way through April. So you have a lot of time to look for those masses. They're mostly going to be probably on oak trees in our area, unless it's an outbreak year. So that's one thing that you can do. And if you do see like a lot of defoliation, you can always contact a local arborist to assess it. Like, is this spongy moth? And if it is, they can put out gyp check traps, which have a chemical that is derived from the nucleopolyhedrosis virus that is able to attract them via pheromone, and then they come into contact with this virus and they die. And there's also BT sprays, which is a type of bacteria that targets, different groups of insects, but they have a BT spray for defoliators that they can put on the leaves, and if they come into contact with it, the caterpillars will die before reaching adulthood. So, great question.
What group specifically does BT,
What was that?
what group specifically does BT target?
So that type of BT is probably going to be like caterpillars. There are other BTs that will go after different kinds of agricultural pests, but the one that you're going to use for sponge moth will interact with most Lepidoptera butterflies and moths. So that's something to be aware of if you have swallowtail butterflies in your backyard. We love having those on our dill and our fennel, and if they come into contact with this particular type of bacteria, they are going to be casualties as well.
Are they attracted to the pathogens? Will those pathogens affect those?
Our pathogens don't normally affect other species other than the spongy moth, but BT is a fungus that is will target a whole order of different critters. So it's like any butterfly or moth that comes into contact with it.
Are there conversations around introducing new species or fungi to like they did in the past? And what are the ethics? Or what are the ongoing ethics conversations around that?
That is a whole kettle of worms. It's the ethics around biological control, but there's no real efforts to look for a new biological control for spongy moths, since the fungus has been so successful at keeping it under control. But we're a lot more hesitant these days to introduce novel species, even if we think they are going to do an effective job at keeping an invasive under control, just because they have the potential to completely explode, and they're not going to have natural enemies of their own necessarily, and it's challenging. I would say biological control is something that works really well in theory, but is a lot more complicated in practice, and people are more hesitant these days to introduce something.
Yeah. That's good.
Yeah, I would say so. It works really well sometimes, but other times it's just a disaster, like with the silk moths, one specific fly.
You're a great presenter.
Well, thank you very much. I appreciate that. I love scientific communication. I would love to go into teaching after I graduate from
You'd be
UVA.
a great teacher. Yeah, you'd be good.
Okay, well, yeah, thank you so much
Thank
for your
you.
time this
Thanks for
evening.
coming out. Very nice.